Welcome to Chapter 10, a review on erosion and deposition. So erosion, remember, is the movement or transportation of sediment. So we're talking about anytime you pick up and move a rock from its original location, you have eroded the rock, you've moved it. If you are walking up a trail and you step in some dirt and it kind of slides out underneath you, you've been an erosional force. You've eroded some of that dirt down the mountainside. Deposition, we're talking about just where we set the stuff down, right? So deposition is like deposit, has that root word deposit in it. So it's the placement of sediment. So when you go to the bank and you deposit money, you're putting money away in the bank. Same with deposition. You go and you put away. Once you're done eroding something, and you're not going to move it anymore, you're going to set it or put it down in a certain place. That's deposition. So if the wind has been blowing something, it's been eroding it because it's been moving the material. Once the wind stops and the material falls, that's deposition. And that's the first type of erosion and deposition we're going to talk about is with waves. So we're talking about at the shoreline. So waves form because the wind blows over the water, sand. So first, so you have waves forming because you have wind, gusts of wind, blowing over the ocean, and it's causing formation of waves. Sand then forms because we end up with like sandy beaches because of because rocks or the waves are crashing down on rocks on the seashore, right? If you have big rocks here, the waves break these rocks down into finer pieces of sediment, and the finer pieces of sediment, eventually we call it sand when it becomes very, very fine. So there are different types of sand based on different locations. So like the color of your beach might be different based on where you are. For example, if you are in Hawaii, you might have a black sand beach because which color? There's igneous rocks, right? Volcanoes have formed Hawaii because Hawaii is over a hot spot we've already learned about. So that's volcanic activity. So igneous rock, when that breaks down, that's black. When it breaks down, you get black sand. If you are somewhere where there's white coral shells, you could end up with a white beach. Like in Florida. Or if like off the coast of California, we have a lot of light-colored, kind of yellow, light-colored beaches. And that's because there is light-colored minerals that make up the rock. And the minerals in the rocks, when the rocks break down, that's the color of your sand. So different materials of the rocks means there's going to be different sand as those break down, right, as they are weathered. and turned into sand. So that means we have different beach colors. All right. Also on the beach, actually, let's go back and look at that. Here, right, as the waves hit the sand here, the waves break is what it's called. And when waves break, they release energy, which NRG is short for energy. And that energy is what breaks up the rocks. That's what acts as a weathering force on the beach. That's how we get sand eventually, right? It's the release of energy from breaking wave or pounding surf, breaks down rocks, makes sand. So also on the beach, as these breaking waves break down and they make little sediment here, they also carry that sediment, so there's actually sand inside these waves in the water. If you've ever gone to the beach and swam in the ocean, you feel pretty sandy after, because there's sand. It's carrying away as the water goes back out. It carries away and it erodes some of the sand and some of the rocks. So we get some different formations on a beach. For example, let's see. We have sea caves. They're little hollows cut in as the waves come in. They pound and you get a little dark sea cave. You have sea arch that previously was part of the headland. Waves have pounded through, so now small animals, right? Waves can go through that sea arch. So you actually have a gap in part of your cliff. This over here is a sea stack. It's like a column of rocks separated from the mainland. So you have the mainland back here, but there's space in between and there's not anything connecting them. Like the sea arch, there's a connection here. I can walk across. There can be a person up here. There can't be a person over here. The sea arch is separate, or the sea stack is separate from the mainland. There's also, let's see. One more thing about the beach before we move on. You have sometimes something called a longshore current, and the longshore current is this zigzag motion of the waves. So the wave is coming in parallel to the shore. It's not coming in straight at the shore, right? It's coming in sideways to the shore, parallel with the shore, and as it does that, so it's bringing in sediment here, right? It's bringing in little sand particles. But when it comes back out at an angle, and then it's going to carry the sand particles over here. So we started at point A, right, bringing a piece of rock, a piece of sand over here to point A. It carried it out into the water, and it's going to carry it in farther along the shore. If I were to extend this picture, and we'll get point B, will be the same piece of sediment. So it's tracking with the wave. So longshore currents move material up and down the coast, and really act as an erosional force as it carries material down the shore. So if something was littered at this point A beach, right, it could be carried way down the coast. Same thing with if there's rocks getting broken down up here, they're going to get carried and deposited at a beach further down the coast, depending on the direction of the waves. Okay. Besides just wave and shoreline erosion, we also talked about wind erosion. And wind erosion has to do with the fact that without, if you don't have plant cover, if you're in a really open land, say, this is my little house, and there's no trees around, the wind is going to come in here, and it acts as a major erosional force, right? All the soil here can get picked up and carried on the wind, and you might get something like let's see, a dust storm forming, like this. Right, all this, see the gray air here? That's because there's not a whole lot of plant cover, and it's really dry, really dusty, so the wind, when it comes along, can just pick up that material, get it up in the air, and it's carried away. We talked about that in light of farming, and that if there's not a whole lot of trees, loss of trees would be, could cause loss of soil, your topsoil. We talked about the Great Depression and the Dust Bowl for a little bit, and that without protection of plants and without protection of water, the soil wasn't moist, it was very dry. The wind could come along and just pick it up and carry it away, and all your valuable topsoil was eroded and carried away by the wind. So one way to protect that, if you're like a farmer, and this is your little farmhouse, and you have all your little crops that you want to grow out here, right, is you can plant something called a wind barrier. So you can plant a tall line of trees, pretend that's a line of trees, right, going back along your property, either in between your fields or in between you and your neighbor. It's a windbreak. It causes the wind to not be able to carry your sediment as far, right? The wind can come and blow a little bit, but it's not going to carry your soil all the way away, right? Your trees are slowing down the wind, and it's protecting your soil. Okay, so then also we talked about saltation, and saltation is that skipping and bouncing of small sediment or sand. Right, the wind comes and picks up small pieces of sediment. If this is your ground here, you have sediment, you have some bigger pieces of rock, you have the little pieces piled on top of one another. Okay, the wind comes along, and it can pick up the little sediment, and it bounces and it moves around. The big rocks here, they're not going to move so much. Bigger rocks are kind of stationary. They might bounce a little bit, right? They might, as the little pieces come down and hit them, right? As they fall and hit them, this piece might move over a little bit, but not a whole lot. Right? It might shift a little bit, not very much. But it's all these little pieces are going to skip around, and they're going to be carried by the wind. They're going to move in the same direction that the wind is going, right? If the wind is going this way, that's the direction the particles are going. Deflation is when, whoops, maybe I'll start a new slide. Deflation is when your sediment is completely stripped away. It's the removal of sediment by wind. Whoops, removal. So in saltation, it's skipping and bouncing, and it's moving in the direction of the wind, but it's not moving super far. It's kind of seeing the same general vicinity. Whereas deflation, you're going to get the complete removal of sediment by the wind. It leaves behind the larger rocks. So again, if we have our ground here, I have a large rock. And say there were small pieces in between and around before. Deflation, when the wind comes, right, it's going to carry all that sediment away. So all these small pieces are going to be gone, and I'm just going to be left with the big pieces. All these big pieces or small pieces are going to be carried away by the wind. All these big pieces will be left. That's called desert pavement. So when all the small sediment is gone, all your small, really fine sediment is gone, you're left with desert pavement. It's the larger pebbles and and rocks, rock fragments. Without your fine layer of like dust or sand particles. Deflation can also cause, besides just desert pavement, it can also cause what's called a deflation hollow. Which would look something like this. The wind comes along, right, and carries all this sediment away here. It used to be full of sediment. This was like all nice and full of sediment, so it was flat, right? But the wind comes and it scoops out part of this ground. It takes this sediment with it. So the wind carries the sediment. You're left with a deflation hollow. Okay, so it's this kind of scooped out area here. Because the wind comes in and scoops out some sediment. The wind can also act as an abrasive force. We've learned this before. Abrasion is that the wind, right, it carries with it. So it picked up some sand along the way as it was blowing. And that sand is going to come and blow against the big rock here. I have some big funny rock tower. And it can like scrape away the side here. It might scrape away a hole in the center. As the wind and these little sand particles are rubbing against this big rock. All right, so if I have one really big rock, abrasive forces, you have this rubbing and grinding. So now my big rock here is going to have a nice big hole in the middle. So that's where the wind is pounding my small sand particles into. And the edges here, if the wind's coming over here, might get rubbed away by the sand. So you have abrasion is the rubbing or grinding, breakdown of rock by sand particles being thrown at it. It's kind of like sandblasting. You're going to polish or smooth your stone with sand by firing sand at a high, fast rate at it. Okay. We talked a little bit about sand dunes. So on your test is going to be a picture. Let me see here if I can draw it. Picture of kind of a funny looking little sand dune. This is my sand dune. And sand dunes, remember, it's just, it's an example of deposition. Sand has been deposited in this big heap, right? When the wind deposits sand, it's gonna just, as the wind comes and then the wind dies off, right? All the particles that were previously on it are gonna fall, and you're gonna end up with a big pile of sand. So sand dunes move around a lot based on the wind. So the wind is moving in this direction towards the sand dune here. This is called my windward. Whoops, that's one word. My windward slope. Right, that's the side that the wind is coming at and touching. On your other side, it's a little bit steeper of a slope. It's called your slip face. Remember, you can slip or fall on your slip face because it's really steep. And remember that sand dunes always move in the direction of the wind. So if the wind is coming this way, my sand dune is going to move this way. Right? It's going to move in the same direction. So if it was previously here, now it might be more like this. It might be moved over a little bit. Right? It will have moved to the right a little bit. Move in the direction of the wind. Right. So on your test, you're going to need to be able to show me which way is the wind moving, right? Should be coming towards the windward slope. And then your other side, the steep slide on the diagram, is the slip face. Okay, besides just wind erosion, we also talked about glacial erosion. Glaciers are very fun to talk about. Glaciers are a river of ice. Remember that this ice was not formed from just water freezing. It was formed from, there we go, there's a picture of a glacier. It was formed from snow being frozen over time. So snow falls on top of snow, on top of snow, on top of snow, and it never melts off, but it freezes instead. You get this special kind of ice that's glacial ice. And we say it's a river of ice because glaciers are moving mass of ice. Right? So it's a river because it's moving. That's why we would call it a river of ice. So it's just this moving, big, enormous chunk of ice. They form where snow stays on the ground year-round. Like I said, the layers of snow are eventually going to turn into ice. And they move due to gravity. Right? They're so heavy, like the layers of ice are so heavy and so large, that causes them to flow and slide. Now they're not moving, so like this one is going to move this way, right? And then downwards in the direction of gravity. They're not going to be moving super fast. They're only moving a few centimeters a day, but that's still relatively fast. You can see the change of how far a glacier has moved. If you look at pictures of like last 20 years, last 100 years, you can really see the difference. And the thicker and steeper a glacier is, the faster it's going to move. As glaciers move, they are what's called a glacial erosion happens. Glacial erosion, we're talking about the fact that the glacier comes in and where is it? The glacier comes in and it moves things and it carves out different really neat geological features. So it erodes the rocks below it. It can pick up and carry rocks underneath it as ice wedging happens, and like if you've put an ice cube on your finger before, it kind of sticks to your skin because of the temperature difference. It does the same thing with the rocks that it moves over. It picks up and carries the rocks. And in that sense, it erodes them, and it also forms grooves in rocks as the ice moves and drags like rocks and sediment over the top of other rocks as it's moving downhill. So this is a picture of a glacier that we're going to label together. You need to be able to label this. Okay, so up at the, we'll start with this. Right here, this little round kind of bowl shape is called a cirque. You can think of like a circus. Circus are round tents. A cirque is this round bowl shape. It's a depression that the glacial ice has cut into the mountain, right? So it's this, like a bowl, and it's a circle. It's been cut in by the ice. Think of like ice wedging, right? Gradually expands and makes the cracks bigger and bigger and bigger as the water gets in a crack, freezes, gets larger again and again over time. So the development of cirques can also form several other features. For example, this up here at the top, this peak is what we call a horn. And the horn, this is an alpine glacier, by the way. It's formed in a mountainous area. There are also continental glaciers, but these features have to do with alpine glaciers. So the horn is like, it's a kind of pyramid shape. Up at the top of your mountain, it looks like a horn. And it's formed because there are 3 cirques, 1, 2, and then the back one you can't see on the other side. Carve it out so that you end up with, here we go, 3. 1, 2, and then 3, there's your other side. 3 cirques, carve out, and you're left with this pointed top, or horn on the top of your mountain. Okay, these ridges here, these jagged ridges, are called, actually there's not one right there. Jagged ridges over here. Arete, and arete are just like a mountain ridge. You have a cirque on one side and a cirque on the other. So you have 2 cirques, 1, 2, and then we get these series of peaks, right? So we have a big cirque on this side and then a big cirque on this side. So you get this series of peaks. It's really not a very good picture. But so you have long, jagged peaks, arete. One single peak is a horn. Then you also have what's called a hanging valley, this right here. It's your hanging valley. It's called a hanging valley because it's a small valley that connects to your main glacier right over here. This big U shape, we'll go with that too. It's called a U-shaped valley. That's formed by your main glacier. You also have some side glaciers going on that would form your hanging valley. And it deposits. You can usually identify it because there's waterfall flowing into your main valley. Right, so as this glacier melts off, it's flowing this water into my main valley, and see my water here. Your main valley, or your U-shaped valley, is characterized by a terminal end, and the terminal end here is water where after the ice melts, it becomes, right, so if you have all this ice up here, this whole valley was full of ice, that was your glacier, and then as it melts, you get your, as it recedes, right, the melting, at one time, the glacial ice was all the way up to the very front. It was all the way up here, and that's what carved out this whole valley. But over time, as it receded and it melts, you get the development of this terminal end. It's just a little like river or lake. All right, so there's all your features of your alpine glacier: cirques, horns, artes, hanging valleys, and U-shaped valleys. All features carved out by the movement of the glacier. As the glacier moves, that's what we call glacial drift. We're just talking about all the material that has been carried or deposited by a glacier. And then there's several different types within this. I'll mention 2 really briefly. The first is a till. Deposited by a glacier. And till, I can't spell. A till is unsorted material that's dropped by a glacier. So as the glacier melts and material is released, you get all sizes and types of rocks. A moraine is the most common type of till. It forms ridges along the edge of the glacier. And then your second type of deposit is stratified drift. And stratified drift, instead of being unsorted, it's the opposite, it's sorted. So you get layers or types of rock. Here they're all mixed, right? You have all different types of rocks, big and small, all mixed together. But here you have like a layer of really small rocks. and a layer of really large rocks, a layer of really tiny rocks. Okay, so we have layers of rocks with stratified drift. All right, besides glaciers, we also talked about mass movement. And mass movement is just the rapid, actually it doesn't have to be rapid. We'll get into rapid mass movement in a minute. But first, mass movement is just the movement of any material, so whether it be rock or sand or ice or snow, soil, any type of material downhill or downslope. Right, so if you have a slope here, if something is moving down, that's mass movement. It matters because we care about how the earth is shaped, right? We're interested in learning about why is the earth shaped this way? Why is this mountain shaped this particular way? Or why are landslides happening, right? We care about mass movement for those reasons. So to understand mass movement, you have to understand angle of repose. Angle of repose, think rest. So when will my material rest? Is it going to be able to withstand me putting it at a really sharp or steep slope? Or is it going to be moving? Is it too steep? Is it going to move and want to be at a more gradual slope? So if that's too steep over here on the left and your material moves, like say it's sand, it's dry sand, and it moves and it kind of falls down here. Now I have my stable slope. So this sand is at the angle of repose because it's not moving. Steep slope is not at the angle of repose for sand, for dry sand. Every different material, every different like wetness, how moist this material has a different angle of repose. For example, if I have moist sand, wet sand, so pretend this is wet sand, I could build a sandcastle and it would stay really steep, right? Steep is okay for wet sand, right? If you've ever built a sandcastle, wet sand, you know that. But you know that dry sand doesn't work too well to build a sandcastle with because the angle of repose is not a very big angle. This angle here is too small. You can't build a very high tower. It'll just move. It'll undergo mass movement until it reaches the angle of repose, and then the material will stop moving. It will rest. Okay, so rapid mass movement, we're talking about how things happen really fastly. There's a sudden shift, and that's really, really destructive. For example, you have rock falls. A rock fall is just when rocks, a big mass of rocks, suddenly fall, largely due to a steep slope and the fact that gravity is acting on them. For example, here's a picture of a rock fall from the USGS. You can see there's kind of a road was going here, right? And if you cut out a road in a steep mountain, you're basically asking for a rock fall to happen. Steep mountain roads are especially prone to rockfall. Just because you cut into the mountainside and now there's exposed rock and gravity, right, wants to move the rocks down. Rocks don't want to just stay floating up here, they want to move down and sit on the ground. So that's what a rock fall is, right? If you've exposed the rock, if you cut into the side of the hill, loosened them, they're prone to a rock fall. Second rapid mass movement is a landslide. Landslide, you're talking about the sudden and rapid movement of a large amount of material down slope. It's not just rocks now, you're talking about, whoa, that does not say landslide. You're talking about also like dirt and soil that's moving. For example, oops. This is from the USGS. This is in California. You can see this major slump happens here. And the slump means that this whole big block of material that was previously up here, right, it moved down slope very suddenly. Slumps are the most common type of landslide. You just have this whole block of material moving down slope over this curved surface. It's left a curved surface behind. It destroys habitats of animals, right? It's very destructive. It destroys homes. It can kill animals, anything that was living up there, the plants. So very deadly. It happens very fast. Once it moves, it's going downhill till it reaches its angle of repose, or until something blocks it. It happens largely due to heavy rains. If you have really heavy rains, it can loosen the soil enough that it could all just go moving down. You could also have deforestation. If you cut out the trees and plants, now there's nothing holding the soil there. Or if you're building and constructing a building on an unstable slope. Unstable slope, it's not sound enough. Now you're drilling into it, you're cutting into it to build, and now it's just going to slide out from underneath you. Could also be due to an earthquake, right? That rapid release of tension in an earthquake, the shaking of ground could cause a landslide. Our third type of rapid mass movement is a mud flow. In a mud flow, you have this, again, rapid movement. You have a large mass of mud that's formed by water, lots of water mixed with soil that forms this really loose mud. So it commonly happens in a mountainous region where there's lots of rain followed by a really dry season followed by a lot of rain, can result in just this inability to soak up the water. You could also be caused by deforestation. Again, there's nothing holding the soil in place, so when the water comes, all this mud is just going to go flowing out. Okay, our last type of mass movement is not rapid. It's the opposite of rapid. It's called a creep. I know it's a funny name. And a creep is when you have this, slow, gradual movement of land down slope. So we're always moving down, right? We're always moving in the direction of gravity. So this hill, this material is moving further and further down. It's always occurring. We can't really see it most of the time, but it's always occurring. You can see, like, when the hillside is eroded because roots are sticking out on the side from a tree. You can see that the hillside has been moving. It's caused by gravity always working. by the addition of water, making the land moist, or like small little mini mud flows, right, as it rains. Burrowing animals, anything that is a weathering and eroding force contributes to this creep, right? The fact that land is always moving downslope in the direction of gravity. All right, that wraps it up for chapter 10. Have your parents sign and date your study guide, saying that you watched this review video.